For my experiment, I rolled a pool ball across a pool table. After uploading the video into Tracker, I could see that the ball had a constant velocity because the graph was linear. The slope of the line represents the velocity. Using the data points collected, I found that the ball had an initial velocity of negative 0.0714 meters per second and was moving in the negative x direction. My observations were consistent with Newton's second law because the net force on the ball was zero, giving the ball a constant velocity. Next, I made a computational model of the experiment using VPython. First, I entered the standard mass of the pool ball and the initial position and velocity found previously in Tracker. Next, I chose a small time step of 0.10 seconds and set it as delta t. To predict the motion of the ball, I made a while loop that continues until 0.582 seconds, which was the time of the last frame of my video. Within the while loop, the net force was set to zero in order to simulate a system with constant velocity. Next, I used Newton's second law equation to predict the new velocity. Consistent with Newton's second law, the new velocity was constant because the net force was set equal to zero. Using the velocity found in the previous equation, I predicted the new position of the ball using the equation position equals initial position plus velocity times delta t. This generated a model of the ball rolling and also a model of the ideal position versus time graph. I then created a graph comparing the ideal run with the experimental run. The graph shows that the ball started at a near constant velocity, consistent with the ideal model. As the experiment continues, however, the ball begins to deviate from the computed path. This is because friction and other outside forces interfere with the ball's path, making the net force not equal to zero. Some experimental errors could have also caused deviations in the data. An example of this is the lighting of the video. I recorded my video using an iPhone in dim fluorescent lighting. This can cause low shutter speed, which distorts the data. Despite the minor differences, this experiment demonstrated a mostly constant velocity and illustrated Newton's second law in the real world.